Light doesn't always travel at the so-called speed of light, c. Instead, it depends on the medium. The relationship between the actual speed of the electromagnetic wave and the true speed of light depends on the index of refraction. A vacuum has an index of refraction of 1, which is why V equals c. In air, our index of refraction is barely above 1, so we usually just approximate that V equals c when we're in the air. Well, because waves travel at different speeds in different media, when light passes from one medium to another, we see a phenomenon known as refraction. The light will alter its path, bending in the new medium, to maintain its frequency and change its wavelength to counteract the change that's happened for its velocity. So how can we tell which way the light will bend? Snell's law gives us this information. Snell's law says that the first index of refraction and the first incident angle, which is defined from the perpendicular, multiplied together equals the same thing for the outgoing light ray. So if we know 3 of these things, we can solve for the 4th. So let's say we have light traveling in air with n1 equal to 1, then entering into water, where n2 is equal to 1.33. If it comes in with a certain angle, we can plug that in, and what you'll see when you plug in 1 and 1.33 is that this angle 2 has to be smaller than angle 1, because n2 is a lot bigger than n1. Therefore, anytime you go from low n to high n, you will bend toward the perpendicular. Now you should now be able to show that if you go from high n to low n, you'll actually bend away from the perpendicular using Snell's law. There's another fascinating thing about Snell's law. There's clearly a limit to what theta 2 can be, because it can't go past 90 degrees. If I rotate this all the way up, eventually it just starts to look like reflection. So there's actually some theta in at which you're going to have total internal reflection where the light will just bounce off. In this case, remember that it can only occur if n1 is bigger than n2, as you'll see when you derive it. So when I have this light come from n1, the heavier substance, to try to get through the surface and refract, instead it will reflect, and we can actually calculate that exact angle by solving for theta 1, where theta 2 is 90 degrees.